Welcome back. So in last class we observed the implementation of one input combinational circuits, two input combinational circuits on LUTs. Now that too in those implementation with different sized multiplexers also we observed. Okay. Now coming to three input combinational circuit implementation on LUT. Okay. So whatever the variable, whatever the input combinational circuit or whatever the size of the combinational circuit, first of all we need to prepare the truth table. Okay, first of all we need to prepare the truth table. So in three variable or three input case, we have 8 possibilities. Okay, those are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So these are the 8 possibilities under 3 variables. So therefore the outputs with reference in the function representation like this, f of 0 0 0, f of 0 0 1, like that. So the 8 outputs we can place it. Okay, so this is the generic truth table for the 3 input combinational circuit. So the output values f of 0 0 0 value depends on based on the combinational circuit or the logic circuit which has the 3 inputs and outputs. Okay, based on the function, the output value depends on 3 variables, right? Now its realization is directly with 8 by 1 multiplexer. With the 8 by 1 multiplexer you can implement this. Okay, or using 4 by 1 multiplexer also you can implement, or 2 by 1 multiplexer also we can implement. Okay, the implementation can be done by either 8 by 1 multiplexers, 4 by 1 multiplexers or 2 by 1 multiplexers. Okay, first of all let me show what is the structure of 8 by 1 multiplexer. Okay, so in 8 by 1 multiplexer case, the RAM size is, or LUT directly you can take, the RAM size has 8 locations because each location can hold 8-bit data. Okay, so therefore the RAM has the values like f of 0 0 0, f of 0 0 1, f of 0 1 0, like that. Okay, so since 8 inputs the multiplexer has, therefore it has 3 select lines, x, y, z. For any combination of x, y, z, one of the 8 inputs is connected to the output. Right? This is the lookup table. Realization using 8 by 1 multiplexer. Okay. So now the same, how can you implement using 4 by 1 multiplexers? Okay, using 4 by 1 multiplexers, that is lower sized multiplexers. For that one we need to divide the truth table into parts like this. Okay, so using 4 by 1 multiplexers means since initially we have 8 possibilities, now we need to divide into 2. Each one has 4 combinations. That is, under x is 0 is one combination, and x is 1 is the another combination. Okay, this is the first part, and this is the second part. The first part is realized by 1 4 by 1 multiplexer. The second part is realized by 1 4 by 1 multiplexer. But the final output again by 2 by 1 multiplexer only. Okay, is it clear? The first part is under x is 0, realized by 4 by 1 multiplexer. Okay, because under yz 4 possibilities are there. Therefore using 4 by 1 multiplexer this first part is implemented. Similarly the second part is also implemented by 4 by 1 multiplexer with 2 select lines yz. Similarly for first one also the select lines are yz. Okay, but final result is through 2 by 1 multiplexer. One input is from the first part, another input is from the second part. Then in that multiplexer the select line is x. X is the select line. Okay, so if x value is 0, the first part result will be connected to output. Suppose if the x value is 1, the second part result will be connected to the output. Okay, so like that the realization can be done. Let us see the diagram of LUT using this 4x1 multiplexers and also 2x1 multiplexer like this. Okay, what I said in the first level, first part functions f of 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0 are the RAM data. Those are the RAM data, followed by 4x1 multiplexers with YZ are the selectants. YZ are the selectants. Similarly, for second part also realized by 4x1 multiplexer with RAM functions are f of 1, 0, 0, f of 1, 0, 1, f of 1, 1, 0, f of 1, 1. Okay, so that the output of this multiplexer is somewhere depends on the again the select line data like YZ. Okay, but what I said, final result is through 2x1 multiplexers only, 2x1 multiplexer only with the select input is x. Suppose if x is 0, the first part result is connected to final output. Suppose if the x is 1, the second part result is connected to the output. Okay, so that this is the lookup table realization. The same thing you can also realize, that is the first part, whatever the first level is there. In the first level case we have 4x1 multiplexers, right? This is you can realize by the 2x1 multiplexers. Okay, so I said in previous class case how the in the previous slide we observed that how a 4x1 multiplexer realization can be implemented using 2x1 multiplexers, right? So observe that part also. Okay, actually here that is not shown. You can see, you can implement directly. Okay, you try the same way how the 4x1 multiplexer can be realized using 2x1 multiplexer. The same concept you can implement in the first level 4x1 multiplexers case. Okay, so that 3 levels we can observe. All in each level the size of the multiplexer is 2x1 multiplexer only. Okay, in each level the size of the multiplexer is 2x1. Maybe in the first level we have the 4 2x1 multiplexers, in second level 2 2x1 multiplexers, and in third level 1 2x1 multiplexer. So like that you prepare and take the clarity if it is not possible. Okay, so always I am available. You can talk and you can take the clarity in the realization, and after preparing the diagram you just post to me, right? Then this is about the lookup table or combinational circuit implementation on LUTs. Okay, next okay, is it clear all of you? So lookup table realization for one input combinational circuit or one variable combinational circuit, 2 variable combinational circuit, 3 variable combinational circuit, like that any length of the combinational circuit you can implement on LUT. Okay, so what is meant by LUT? LUT is a lookup table concept. It is realized the realization of LUT uses memory and multiplexer. The size of memory depends on the given function. Okay, the given function, and the size of multiplexers are also given function. The minimum size multiplexer is 2x1 multiplexer, and the maximum size multiplexer is depends on the number of variables. Okay, so like that the lookup table implementation we can observe. Okay, then coming to another part, that is combinational circuit design. design. Under this we have three things: analyzing the problem to be solved, selecting a solution method, implementing the solution. What we have under this is okay, some examples are there, how to implement that example, but that we can see in the fresh class. Okay, now I am going to stop this one. You prepare some more lookup table realizations for different functions having 3 inputs or 2 inputs or 4 inputs, like that. Okay, so like that you prepare some lookup tables. Okay, so after that, if you have the clarity, I think you can easily clear with practicing. You can easily implement the lookup table realization, right? Okay, now I am going to stop this session.